Welcome back to today's session. In the previous session, we saw if the problem was unbalanced, how do we get it to standard form and then apply our IBFS techniques to solve the problem. Today, in today's session, we will be looking into how to handle a maximization case in transportation. See, in transportation problem, the standard form is balanced minimization case. But if the problem is not in minimization case, if at all it is in maximization case, then we will have to bring it to standard form, right? So when do we say a problem to be in its maximization case? When the objective of the given problem is to maximize the profit, then the problem is said to be maximization case. Very much similar to whatever you had in your assignment problem. So if the problem is maximization, it has to be converted to standard form, that is minimization. So how do you convert? Once again, very much similar to whatever you did in your assignment problem method. The profit matrix that is given has to be converted into a loss matrix by subtracting all the elements of the given profit matrix from the highest element of the matrix. So identify the maximum element or the highest element in the profit matrix, subtract all the elements from that highest element so that the profit matrix will get converted to loss matrix. So our maximization case problem will get converted to minimization case. Hope you have understood. So when we are computing the TTC, the total transportation cost, so the cost has to be considered from the original problem, that is from the profit matrix. For the final TTC calculation, consider the values of the profit matrix to get the optimal transportation value. Hope you have understood the concept. So to understand this in a better way, or to understand it more clearly, we will consider a problem and try to solve it, right? So we take a problem, obtain the initial basic feasible solution of the transportation problem to maximize the profit using NWCR and LCM. So I will be solving this problem for IBFS using both NWCR and LCM, and whose profit matrix is as given below. So they have given a profit matrix here. So the problem contains three origins, O1, O2, O3, and four destinations, D1, D2, D3, and D4. The supplies at the origin are 100, 30, and 70. The demands are 40, 70, 60, and 30. So if you observe, 70 plus 30 is 100, 100 plus 100 is 200. So the total of the supplies is 200. So 70 plus 30 is 100 here, and 60 plus 40 is also 100. So 100 plus 100, 200. So the demand totals is also 200. So now it is balanced, but the given matrix is not the cost matrix, but it is a profit matrix. So we will have to convert this profit matrix into a loss matrix. So the profit matrix given to us is 40, 25, 22, 33, 44, 35, 30, 30, 38, 38, 28, 30. So we find that the largest value is 44. So we'll have a look at it. So since summation AI is equal to summation BJ equals 200, the problem is a balanced transportation problem with profit matrix given. Hence, maximization case has to be converted to sorry, spelling mistake, to minimization case, subtract all elements of the profit matrix from the max element 44 to make it a loss matrix. So 44 minus 40 will give you 4, 44 minus 25, 44 minus 22, 44 minus 33, 44 minus 44, 44 minus 35, 44 minus 30, 44 minus 30, 44 minus 38, 44 minus 38, 44 minus 28, and 44 minus 30. This calculation has to be done, and the resultant matrix will be 4, 19, 22, 11, 0, 9, 14, 14, 6, 6, 16, 14. Right? Now we have a loss matrix so that the problem has come to its standard form. Now we can apply NWCR on this. So when you are applying NWCR, northwest corner, that is the top left corner has to be picked. Top left corner is 1, 1. So you are supposed to satisfy or transport or make an allocation here. So demand is 40, supply is 100. So how much you can supply? 40. So transport 40 at 1, 1. So at 1, 1, we make an allocation of 40. Demand becomes 40 minus 40 equals 0. Supply becomes 100 minus 40 equals 60. So allocation at 1, 1, 40. Okay, 1, 1, 40 units. So this, 1 minute, let me select the highlighter. So this column is gone now. Oh, color. This column is gone now. So we are left out with this portion of the matrix. In this portion, we are supposed to pick the top left corner. The top left corner is 1, 2. Supply is 60, demand is 70. So how much can you transport? Yes, 60. So 60 units will be transported across 1, 2, and the supply becomes 60 minus 60, 0. Demand becomes 70 minus 60, 10. Fine. So we make an allocation at 1, 2 with 60 units. 1, 2, 60 units. So we see this column is already gone and this row is gone now. Now the remaining matrix is only this much. In this, the top left corner is 2, 2. So this has to be picked. Supply is 30, demand is 10. So how much you can transport? Yes, 10 units. So you will transport 10 units across 2, 2. So supply becomes 30 minus 10, 20, and demand becomes 10 minus 10, 0. Right? So the allocation is at 2, 2 with 10 units. So this column is gone, this column is also gone, and this row is gone. Fine. Now the remaining matrix is only this portion. In this portion, which is the top left corner, this one, right? 2, 3 will be the top left corner. So therefore, we need to make an allocation here. Supply is 20, demand is 60. How much can you transport? Correct, 20. So the supply becomes 20 minus 20 equals 0. Demand becomes 60 minus 20 equals 40. Okay, so I make an allocation at 2, 3 with 20 units. Fine. So now this row is gone. This row is also gone. Then this column is gone. This column is also gone. Now the remaining portion of the matrix is only this much. So which is the top left corner? So obviously 3, 3. So how much can you satisfy here? Demand is 40, supply is 70. Yes, you can satisfy only 40. So the demand becomes 40 minus 40, 0. Supply becomes 70 minus 40, which is 30. So I make an allocation of 40 units at 3, 3. At 3, 3, 40 units. So this column is gone. This column is gone. Oh, sorry. I haven't made it 0. So this column is also gone. This row is gone. This row is also gone. Now only left out is 14. Right? Only left out is this node. So how much allocation you can make? So as we see, the supply and demand will match. This row gone, this column, and this column is gone. Okay, I'm left out with the supply of 30 and demand of 30. So whenever you have a single cell left, if at all you have solved the problem correctly, I've already told you, the supply and demand will match. Now the supply and demand is matching, both are 30. So you get an allocation of 30 at 3, 4. And the supply becomes 30 minus 30, 0. Demand becomes 30 minus 30, 0. So this row and this column also is gone. I get an allocation of 30 units at 3, 4. At 3, 4, I get an allocation of 30. So what is the next step? Obviously calculating the total transportation cost. So 40 units is transported. What is the cost here? So it is 40. I had 40 here. That is why I had got 44 minus 40 as 4. So if at all I perform 44 minus 4, I get 40. Okay. So the cost is 40 into 40. Here 60 units are transported. And what is the cost? 44 minus 19 is 25. So the cost was 25 in the profit matrix. So next, 10 is the number of units transported. And what is the cost? 44 minus 9. 44 minus 9 is 35. So the cost was 35. 10 into 35. What about here? 20 units are transported. What is the cost? 44 minus 14. So the cost was 30. So 20 into 30. Here 40 units are transported. What is the cost? 44 minus 16 is 28. So I get a 28 here. So 40 into 28. Here 30 units are being transported. What is the cost or the profit? It was 44 minus 14. 44 minus 14 is 30. So the cost will be 30 into 30. So 40 into 40 is 1600. 60 into 25 is 1500. 10 into 35 is 350. 20 into 30 is 600. 40 into 28 is 1120. 30 into 30 is 90. So when you add up all these values, 1600 plus 1500 plus 350 plus 600 plus 1120 plus 900 gives you 6070. So the IBFS TTC using NWCR for this problem is 6070. Now let us try to solve the same problem using LCM, right? Since the supply total and the demand total is 200, it is a balanced transportation problem, but profit matrix is given, therefore convert it into minimization. How do you convert it? By subtracting it from the max element 44. So the resultant matrix that you get is 4, 19, 22, 11, 0, 9, 14, 14. 6, 6, 16, 14. Okay. So now we have the loss matrix and the problem is in its standard form. So now I can straight away apply LCM. So how do you apply LCM? Look into the loss matrix now. Whichever is the least cost, I need to apply allocation there. So least cost is 0. So how much I can transport here? Supply is 30. Demand is 40. So how much I can transport? Correct. 30 you can transport. So I make an allocation of 30. So the supply becomes 30 minus 30 is 0. Demand becomes 40 minus 30, 10. So I have an allocation at 2, 1 with 30 units. So what happened now? This row is exhaust. Now the remaining loss matrix that I have is 4, 19, 22, 11, 6, 6, 16, 14. So which is the least cost? Correct, 4. So here I am supposed to make an allocation. How much will you make? Demand is 10, supply is 100, 10. So you can transport 10 across 1, 1. So the supply becomes 100 minus 10, 90. Demand becomes 10 minus 10, 0. Okay. So I have an allocation at 1, 1 with 10 units. So the first column is gone and the second row is gone. Now the remaining loss matrix is 19, 22, 11, 6, 16, 14. So which is the least cost? 6. So when I have the least cost as 6, I need to make an allocation here. How much can you allocate? Supply is 70. Demand is also 70. So you can satisfy 70 here. Right? So supply becomes 70 minus 70 is 0. Demand becomes 70 minus 70 is 0. Fine? So I get an allocation at 3, 2 with 70 units. So this row was gone. This column was gone. Now, see, as I said, only one of them has to be cancelled. So even if you cancel both, it should not be a problem, right? So don't get confused. So even if you cross both, the problem solution will remain the same. It doesn't change. So now the remaining matrix that I have is 22 and 11. So which is the least cost? Obviously 11. So how much can you transport across 11? Supply is 90, demand is 30. Right? You have 90, you want only 30. So you just have to transport it. So when you transport 30 units, you get 90 minus 30 equals 60 as the supply, and demand is 30 minus 30 is 0. Right? So you get an allocation across 1, 4 with 30 units. 1, 4, 30 units. So the first column is gone, second column is gone, fourth column is also gone, second row is gone, third row is also gone. What is left out? Only one cell, 22. When a single cell is left, what have I told? The supply and demand should match. Is it matching? Supply is 60, demand is also 60. So satisfy 60 across 1, 3. Supply becomes 60 minus 60 is 0. So this row gets cancelled and demand becomes 60 minus 60 is 0. This column also gets cancelled. I get an allocation across 1, 3 with 60 units. Okay. So once all the demands and supplies are satisfied, what is the task left? You're supposed to calculate the total transportation cost. So calculate the total transportation cost. Number of units transported 10. Profit will be 44 minus 4, 40. So 10 into 40. Next, 30 units have been, 60 units have been transported and the loss is 22. The profit will be 44 minus 22 is 22. So 60 into 22. Next here, 30 units have been transported. Loss is 11. Profit will be 44 minus 11, 33. So 30 into 33. Okay. Here the number of units transported is 30. Loss is 0. Profit will be 44 minus 0, 44. So I get 30 into 44. Next year I have transported 70 units. Loss is 6. Profit will be 44 minus 6, 38. So it will be 70 into 38. 10 into 40 is 400. 60 into 22 is 1320. 30 into 33 is 990. 30 into 44 is 1320. 70 into 38 is 2660. So when you add up all this, 400 plus 1320 plus 990 plus 1320 plus 2660. So I get 6690. Right? Here, once again, you observe LCM is giving you a better answer when compared to NWCR. Your LCM is giving you optimal transportation cost to be 6690. NWCR is giving you 6070. So which is better? So LCM is better, right? In most of the situations, LCM gives you a better solution than NWCR, except in very few rare cases where NWCR gives you a better solution. Hope you have understood how to solve a maximization case problem. Thank you for your patient listening. Kindly be home, be safe, have a nice time, enjoy.